This method can help answer key questions in the fabrication of micro and nanostructures for observation by transmission electron and X-ray microscopies. The main advantage of this technique is that it allows sample fabrication on nanometer-thin silicon nitride membranes, which is the requirement for observation by transmission microscopies. Demonstrating the procedure will be Meena Dhankhar and Marek Vaňatka, grad students from my laboratory.
To begin, place the 30 nanometer silicon nitride membranes on a hot plate at 180 degrees Celsius and bake them for 15 minutes to remove any moisture. Put the adapter onto the spin coater and then place the membranes into the adapter. Spin coat 950K PMMA resist at 3000 RPM for 1 minute to produce a film thickness of approximately 200 nanometers. Then post-bake the samples on the hot plate at 180 degrees Celsius for 3 minutes to harden the PMMA layer. To carry out electron beam lithography, draw the desired pattern of disks in the Graphic Database System, or GDS, format, and upload it to the electron beam lithography system. Load the samples into the e-beam writer system. Then set the stage and beam. Expose the disk area to an electron dose of 260 microcoulombs per square centimeter at a beam energy of 20 kiloelectron volts. Following the exposure, immerse the samples in a methyl isobutyl ketone.